Hi everyone, this video is going to cover the binomial distribution. So the learning goals are to recognize when a situation will give rise to a binomial distribution, represent these distributions as tables or graphs to calculate the expectation, and then also to solve problems involving binomial distributions. So here are some keys that we've talked about before in class, but we'll just sum it up here. Binomial distributions happen when trials are independent and the results are either a success or a failure. Probability of a certain number of successes follows this formula over here. N represents the number of trials, P is for the probability of success, and then 1 minus P is the probability of failure. So you just subtract 1 with whatever the probability of success is. And that's the expectation for a binomial distribution. Just do N times P. There's a proof of that. I shared a link with the video if you're interested in looking at the proof. Alright, so let's go with an example. A spinner is 1/4 yellow and 3/4 blue, and it's spun 3 times. And we're going to consider a win when the player spins yellow. So we're going to verify that the situation is a binomial distribution. So remember, the keys are that it's independent. So is everything independent? Yes, it is. So the trials are independent, right? The spinner doesn't remember the results from before. Okay, so every spin is independent of each other. And it's success or failure, right? So those are the keys. Okay. Whoops, failure. Okay, so both of those things are fits. So we know that this is going to follow binomial probability distribution. So what is the value of P? Well, remember, P is just a probability of success. In this case, there's just a 1 in 4 chance of winning. And we can simplify that to 0.25. Okay, that's going to come in handy when we're going to do our calculations. Alright, now we're going to create a table to represent the probability distribution for the number of wins. So remember, we're going to use this formula, P, the probability of winning any number of times, okay, is equal to N choose X times the probability that's raised to the power of X, and then 1 minus P raised to the power of N minus X. In this case, N is the number of trials, so that's going to be 3. And the probability, like we said before, is 0.25. Okay, so we're going to follow that. So X is going to be either 0, 1, 2, or 3, okay, depending on the result that we are focusing on. So in this case, what's the probability of winning 0 times? So that's how we write that. The probability of winning 0 times is equal to 3 choose 0 times the probability raised to the power of X, and 1 minus P is just 1 minus 0.25, which is 0.75, and that's raised to the power of N minus X, which is just 3, right? So just focus here. So it's N is 3, take away 0. That's why it's 3. Let's just fill in all the formulas. Okay, so if it's 1, so X is equal to 1. Whoa, that's a funky bracket. Okay, 3 choose 1 times 0.25 raised to the power of 1, and then 0.75 raised to the power of 2. Okay. You see that there's a sequential pattern that's happening here. Okay, let's say X is equal to 2. So that's going to be 3 choose 2 times P raised to the power of 2, and then 1 minus P is 0.75 raised to the power of 1. Okay. And P, X is equal to 3, will be 3 choose 3, 0.25 times, to the power of 3, and 0.75 raised to the power of 0. Okay. So, like a really good cooking show, I've already calculated these somewhere. Where did I write that down? Here we go. So when X is 0, so this is going to be 0.4219. This is 0.4219 as well. This is 0.1406 and 0.0156. Okay, so those are the probabilities of winning no times, one time, two times, or three times in 3 spins. Okay. Just to make things convenient, remember when we're calculating expectations, is just the sum of the products of the value and its probability. So we can just multiply that really quickly over here. That's going to be 0. This is 0.4219. This is going to be 0.1406 times 2. That's 0.2812. And then 3 times 0.0136 is 0.0468. Okay. So that'll come in handy in a little bit. So this part here, what is the probability of winning at least 2 times? Well, the probability of winning 2 or more times, okay, so we would write that, right? X is greater than or equal to 2. There's 2 ways of calculating this, if you think about it. We can just add up the probability of winning 2 times plus the probability of winning 3 times. So that's going to be 0.1406 plus 0.0156. Right? When we add them up, we get 0.1562. Okay. So that's one way of doing it. Remember, there's also the indirect method. We could also think about this as 1 minus the probability of the other outcomes, okay, that we don't include. So that could be 1 win, but we also take away the probability of getting 0 wins. Okay, so this is 1 minus 0.4219, take away 0.4219 as well, and you'll get the exact same result. Okay. You don't have to do it 2 different ways, but I just want to show you the 2 different ways because one will be more handy than the other usually. Okay, let's graph the probability distribution. So let's say that these are all the values of x, and then here this is the probability of x. Okay, so you can have 0, 1, 2, or 3 ways, or 3 wins. I'm just going to change the color. I'll do that in a second. We'll scale this as 0.1, 0.2, 0.3, 0.4, and that'll be 0.5. So we just draw bars going up, straddling the middle. So x is going to be 0.42, so that might be somewhere around there. Okay, this is going to be a very crude drawing, I apologize. A is going to be around the same thing. 2 is 0.14, so that's around here. And 0.016, that's going to be somewhere low. Okay, that's about as good as you could do hand, like freehand. Okay. And the expectation. So remember, you can add up that final column, or you could use this formula here. The expectation is n times p. So n, remember, is 3, and the probability was 0.25. So we'll get 0.75. So again, if you add up the final column in that distribution that we just did, you'll get 0.7499. If you round it up, you'll get 0.75. So those are the basics of the binomial distribution. So I'd like you to give the following questions a try. So here's a game of chance, involves 4 red cards and 1 black card taken from a traditional deck. Here's an example. A player receives a point if he or she draws the black card from the set. Okay, and a total of 4 draws are going to be performed with replacement and shuffling. Okay, so the card goes back in for every trial. Okay, so here's a probability distribution and expectation charts. Why don't you fill that in? You're going to need to know what n is equal to. Remember, that's the number of trials. And p, the probability of success. And then once you've done that chart, try to answer the question that's down here. What is the probability of earning at least 2 points? and then would 2 or more points be a higher total than expected? Okay, so pause the video, try the questions out, and then when you're ready to check your work, just press play. Okay, let's fill this in together. Well, you've done it already. So n, okay, just a little side note here. The n should be 4 because there's 4 draws. And because there's a 1 in 5 chance of winning, the probability would be 1 in 5. Or you can think about it as 0.2. Okay, it doesn't really matter. Okay, so the probability of getting 0 victories or 0 successes is, let's go, 4 choose 0 times 0.2 to the power of 0, 0.8, which is the probability of failure here, to the power of 4. Okay. The probability of winning 1 time would be 4 choose 1, 0.2 to the power of 1, 0.8 to the power of 3. The probability of winning 2 times, and so on, right? 0.2, 0.8 to the power of 2. X is equal to 3. That'd be 4 choose 3, 0.2 to the 3, 0.8 to the 1. And the probability of x is equal to 4 would be 4. Let's go. 4 choose 4, 0, come on, 0.2 to the 4, 0.8 to the power of 0. Right, so this would be 0.4096. The second one is the same again. 0.1536, 0.0256, and then 0.0016. Now the expectation column here, you would have 0, 0.4096, 0.3072, 0.0768, and 0.0064. Okay, so hopefully you got those values. And so what's the probability of earning at least 2 points? So remember, the probability of at least 2 points, we would write P, x is greater than or equal to 2. So we would add up 2, 3, and 4. We can do that. Or we can do 1 minus the other 2. Okay. So I'll just do the indirect method here. 1, take away the probability of winning 1 time. Subtract also the probability of winning 0 times. Right? That's 1 minus 0.4096. Take away 0.4096. So you should get 0.1808. So that's the probability of earning at least 2 points. And then would 2 or more points be a higher total than expected? Well, what is the expectation? Be n times p. That's 4 times 0.2. That's 0.8. So 2 or more points would be higher than expected. Okay. So there we go. Okay, let's solve one more problem. At a Coca-Cola bottling plant, about 6% of the glass bottles produced are defective. A quality control inspector randomly chooses 15 bottles for testing. So is this an example of a binomial probability distribution? Well, since it's in the video, of course it is. But we're going to assume here that the glass bottles, the defective ones, don't depend on each other. Okay. And also it's success or failure because it's either defective or it's not defective. So what is the probability that the inspector finds 2 defective bottles? So we just need to know one possibility, and we have to calculate the probability of that happening. So this is the probability of when x is equal to 2. Okay, so we're going to use our binomial probability distribution. our binomial probability formula, we need to know that n, the number of trials. In this case, they're choosing 15 bottles, so that is the number of trials. And the probability of finding a defective bottle. So even though it's defective, that's what we're looking for. So that's our quote-unquote success. Okay, so the probability of getting a defective bottle would be 0.06. All right, so we can use those numbers. So it's 15 choose 2 times 0.06 to the power of 2. And then 1 minus 0.06 is 0.94 to the power of 13. Okay. We crunch the numbers and we get 0.1691. So that's the probability of finding 2 defective bottles. What's the probability that they find at least 2? So that can be 2 or 3 or 4 or 5 or 6 all the way up to 15. Right? We could add up all of those probabilities, but that would take a long time to do. The faster thing in this case, right, to find out x is at least 2 would be to do 1 minus the probability of getting 1 bottle minus the probability of finding 0 defective bottles. Well, that's 1 minus. Now the probability of 1 would be 15 choose 1 times 0.06 to the power of 1, 0.94 to the power of 14. And then the probability of finding 0 defective bottles would be 15 choose 0, 0.06 to the power of 0, 0.94 to the power of 15. And this becomes 1 minus 0.3785 minus 0.3953. And that'll get us, whoops, let's go back here, 0.2262. Okay, so that's the probability of getting at least 2. Now finally, how many defective bottles should the inspector expect to find in a batch of 15 randomly selected bottles? Well, that's just the expectation, and the expectation is n times p, so that's 15 trials times 0.06. So that's 0.9 bottles. Whoops. So on average, they'll find less than 1 bottle. All right, so hopefully all of those examples have made binomial distributions a little bit more clear. There's a lot to take in, so if you need to watch it again, feel free to do that. And yes, well, thanks for watching.